because of the fact that it gets to be too much. So each chord now has two parts to it. Do you agree? All we have to do is multiply the parts. Chunk times chunk is chunk times chunk. Chunk, as in chunk, like C-H-U-N-K. You don't like the word chunk? Why?
It sounds no, say the word cheese curd.
Have you guys seen
Oh, okay. What's that?
Cheese curd.
Who's that movie called?
Oh, yeah, Goonies.
Yes.
Rocky Road.
I love
Yeah.
that movie.
Chunk, hey, you guys.
You guys don't, have you guys not seen it?
You've never seen the movie Goonies?
How?
That's my favorite movie.
I was gonna say, I'm like,
I've
wait.
never seen it.
Oh, Tope. All right.
Was what?
Back into play. Oh, so much in just this one section. This one section uses up about all of the different algebra things you guys learned about last year. Okay. So here's an example where you have your two chords intersecting inside of a circle. You're not working with angles, you're not working with arcs, you're working with segments. This is the type where you're going to see chunk equals chunk times chunk. And you write it out. X plus 2 times x plus 1 is x times x plus 4. Right? So this is where we have to FOIL and distribute. You guys all remember FOIL, right?
Yeah.
First, outside, inside, last.
Yeah.
Now there's not much of an easier way to do it, unfortunately. Bless you. So you FOIL that one out. We're going to get x squared, a 2x, a 1x, and a 2. On the other side, when you distribute out your x, you're left with x squared, x squared plus 4x. Everybody okay with me so far?
Yep.
All right. Quick distributed property. So combine all your like terms on the one side. So you have 2x and 1x gives you how much? 3x. So you just rewrite one more time. X squared plus 3x plus 2 is x squared plus 4x. What happens with the x squareds? They cancel each other out because if you subtract it going from left to right or from right to left, they just drop. So the x squareds go away. And you're left with 3x plus 2 is 4x. Who are you going to pick on, 3x or 4x? 3x. Subtract it over, what do you get? There we go. There's just a lot of algebra in this. Okay, you're going to see a lot of algebra. And I try to do my best to make sure that I have plenty of examples today of all the different types that we're going to have to worry about. Okay? I'm still trying to, this is the last section in chapter 10, so we'll probably test towards the end of the week. I don't know if it'll be Thursday at the earliest, Friday at the latest, just so you guys know. That's where I'm looking at, okay? What's that? Yes. Not terrible? Yes, ma'am?
We're not going to review like we always do, right?
No, not at all. I'm just going to give you the test tomorrow. I mean, Thursday.
Alright.
Of course. Come on, I'm a jerk, but I'm not that bad of a jerk, right? Yeah, Jaylee, I've got a couple of really good review things already planned out. Okay. Once again, I kind of just reused the same picture a few times, and I'm just kind of setting it up in terms of the algebra. I'm just trying to show you guys all the different types of algebra that you have to worry about, or not so much worry, but let's rephrase that. The types of algebra you have to remember. Okay. Put away your phone, please. Come on. Okay, you can do it. One of the things that does come up pretty regularly, especially in this section, is that you guys will notice that there's a lot of information in one of the problems. What I try to do, obviously with the smartboard, it's pretty easy for me to distinguish where all the segments are being labeled and whatnot, like as far as the x values and all those terms. But sometimes in books and in and on like worksheets and whatnot, they might use arrows to point to things. So it can get kind of messy when they have the small print. Just a little FYI there. So again, I get the idea of I've got the two chords that meet in the middle, or not in the middle, but they meet inside the circle. So I have chunk times chunk will equal chunk. It's chunk. So you write it out. Oops. Uh, 3x times x plus 1 is x times 4x. Did it matter if I wrote the 3x before the x plus 1? No. I'm just multiplying, so the order of operations doesn't matter when you're multiplying. So you get the, 3 times 4 is the same thing as 4 times 3, the commutative property. Okay? Whenever I see what's called a monomial, numbers and variables put together by multiplication, if that's it, I just do that. Yes, ma'am? Okay. I see what you're talking. Don't always pigeonhole that it's going to be these letters like that. What I was trying to show is that this segment times this segment is this segment times this segment. And this just labeled as A, B, C, and D there. This could have been X, W, X, Y, Z, or anything, okay? I just want you to see it's chunk times chunk, chunk times chunk. Does that make sense? Yeah. Yeah, Tom? Yeah. All right, so I distribute this one out. When I distribute this out, I get 3x squared of 3x equals 4x squared. We okay with that? Remember multiplying together with things, right? I hope that made no sense. Multiplying together with things. Math. Now, when you do this, you have to set aside equal to 0 because you have x squared terms. Oh, I'm sorry, G. Oh, never mind. I thought your arm was up.
Oh,
Okay. So, in this case, I have x squareds on both sides, but one of the coefficients, the number in front, is bigger than the other. So who am I going to pick on, the 3x or the 4x? 3x squared or 4x? 3x squared. So I'm going to subtract the 3x squared to the right. I'm also going to subtract the 3x over to the right to set one side equal to 0. And I get that. I'm solving what's called a quadratic. To do this. When you are solving for x, when you have x squared terms, you need to set one side equal to 0, so that way you can factor the other side. Yes, there's lots of factoring. Sorry I brought back the bad F word. It's not like the fun F word. Fun. So the first rule of factoring is to find the GCF. What do these two terms have in common? X. So I can factor out an x.
You're welcome.
These are now what you call terms. Terms are things that you multiply together to get a trinomial, to get a binomial, to get your x squared. What you've gotten here now are the fully factored form of some equation. Now, when you get to your terms, which generally are in parentheses, that means you're going to set those equal to 0 to find what's called, well, technically called your 0. So what you do now is you set both of these terms equal to 0, and then you solve them for x.
That's correct.
Yep. The first one's really easy. It's 0. The second one, you have to pace yourself to do one step. How do you get x by itself here? You add the 3 and you get x equals 3. So you have two possible answers for this, 0 and 3. But if you look at the diagram, if I substitute in for 0 there, hi, I forgot to ask, how was your weekend? I'm starting off on a new leaf. I'm not making fun of you this week.
Wait, you actually enjoy spending time with your family?
So if I put in 0 for x here, what do you get? 0. Can you have a segment length that is 0? No, that won't work. So I'm going to exclude that answer. It's an answer, it's just not an answer for us.
It's not the right answer.
Correct. Sometimes you're going to get that, and we've had this before, where you had, remember how we've had plus minus answers before? Sometimes the negative works, sometimes it doesn't. It's the same basic idea here. You're going to see that quite a bit. All right? So then I only have one answer in this case, and it's going to be 3. Not too terrible? At least not yet. Let's try another one. Oh. Did I skip? Oh. Huh. I must have skipped over one. Oh well. No, I must have accidentally forgot to put one on there. Oh well, no big deal. Pay no attention to this line here. Yes, ma'am. Again, I wind up with 2 segments that are intersecting into one another inside the circle. That just means chunk times chunk equals chunk times chunk. It's a really bad diagram. Let me try and redo that one real quick. Okay. So that just means that, yes ma'am?
Will you always have to do like A times B equals CD, or can you do C times D equals A and B? Or
Yeah, that's fine.
okay.
Because
Go
does it
either
2
way.
equal 2?
Yes.
And 2 equals 2 going the other way?
Yeah. Okay.
Remember, what you're talking about is something like this. X equals 3 and 3 equals x. It means the same thing.
Okay.
Okay? So here again, you've got chunk times chunk is chunk times chunk. So you get 4x is 8 times 6. So what's 8 times 6? 48. Divide out by your 4, and you get 12. So I wanted to start with something that looked awful, and then show you guys, hey, it's not always going to be that bad. Multiply something out. Okay? So there's problem style number 1, which means we have 2 more to go. So that means we are 1/3 of the way done.
You have 24 minutes.
Ah, no worries.
Are you sure?
Sure. Sometimes you'll have diagrams that look somewhat like this, where you have 2 segments that intersect or have a starting point on the outside of the circle, and those 2 segments go through the circle. When a segment goes through a circle, what do we call that segment? Remember? The tangent touches it at one spot. This goes through the circle and touches it too. Yeah. Not dealing with angles. Segments. What's that segment called? A what? Secant. Yeah, it's called a secant. So when you have what's called a secant, 2 secants, the 2 that go through, do you guys agree that you start out with 2 segments? Those 2 segments are the whole segments. Are you okay with that? I just call those both wholes. The whole segment is made up of 2 parts, correct? There's an outside segment and an inside segment. You okay with that? And there's another one just like that on the other side. Which means, if you look at it, the whole segment is made up of two parts, an outside part and an inside part. So to create the whole, what would you do to the outside and the inside? You just add it together. You okay with that? So here's what I want you to do. Anytime you see, if you have to find segments and you're dealing with an example or a picture that looks like this, it's the outside part times the whole thing equals the outside part times the whole thing.
Looks like a penguin with your eye.
I've heard that before. So you have this whole idea of, or I want to see a whole idea. You have this idea of outside and a whole. Outside times the whole is outside times the whole. And the whole thing is made up of the two parts, the out and the in. And you, to figure out what the whole thing is, you just add them together. Okay? So let me show you an example. You have an outside and a whole thing. Outside and a whole thing. To be honest with you, I wouldn't even bother worrying about the lettering right now at all, because it doesn't happen all the time. They might ask you, hey, what is segment CD going to equal? Or hey, what is ED equal? What is the whole thing? You know, you might have to do something like that. But for right now, let's just worry about how to do the algebra. So, if I do an outside and the whole, what's my first outside? 4. So I have an outside times whole is outside. If 4 is the outside, what's the whole thing? 9. Good. What's the outside of the next one? 3. And what's the whole thing? 3 plus x. Did I say earlier? I said the whole. Oops, too far. The whole is made up of the out plus the inside. Not multiplying. We're adding them together. Okay, it's a very common mistake. Multiply and distribute. What's 4 times 9? 36. So we have 36 is 9 plus 3x. Okay? And now you're back to a very quick 2-step equation. When I have to do 2 steps here, first thing I do is subtract out the 9. What do you get? 27. Good. And then lastly, divide by 3, and you get? 9. You're done. Outside whole, outside whole. Okay? To get that whole segment, you're just adding them together. Don't multiply, you're adding them together. So I showed you the easy version of that. What do you think I'm going to show you next? The algebra. Yay! Oh, I'll skip that one. Go right to that.
I was about to say, that looks so scary.
Yeah, you get fractions. But
What fractions do we do?
they cut me into pieces.
I think you cut them in pieces.
So I have an outside and a whole, outside and whole. I would recommend a lot for this first day or so to write it out like I was just doing, with outside times the whole equals outside times the whole. The reason that I want to do that is because it'll help me remember what goes where. What's my first outside? 3. The whole thing then is going to be 3 plus x plus 2. What's 3 plus x plus 2? 5 plus x or x plus 5, right? That's how I get the whole thing. My second part. Outside, x plus 1. The whole thing is x plus 1 plus x minus 1. When you combine like terms there, how many x's do you get? 2 of them. So you get 2x, and then what's 1 minus 1?
0 minus 1. Oh my gosh, 0.
So x plus 1 plus x minus 1 is 2x. Does it matter what side I put something to do that I have to distribute?
There's 2 in that.
What I mean is, we normally, when we write distributed property, it's usually on the left going to the right. But can't I do it going from right to left too? It means the same thing. So first I'll distribute this, and I get 3x plus 15. On the other side, I'm just working the other way. I get 2x squared plus 2x. And now comes the point where you guys are going to hate me more than you normally do. I don't have x squareds on both sides where things are going to drop out. When that happens, that means I have to set one side equal to 0. Okay? And when you have to set a side equal to 0, what you want to do is set the side that's to 0 that doesn't have the squared terms, or if it did have a square term, it's the lowest coefficient square term. So if I had like a 2x squared on one side and a 1x squared on the other, I'd move everything. All right? Which means I need to move the 3x and the 15 to the other side. Huh. You got a package from Amazon. You get 2x squared.
Oh, that's why.
Yeah, sorry, you were in the wrong spot. You probably didn't see our statement. Oh, that looked like a +5. Sorry, my handwriting has really gotten bad today. Don't say just. So I have 2x squared minus x minus 15, which means I have to factor that. And if you remember, when you factor terms where you're factoring trinomials, which are quadratic, which this is, when you're factoring stuff like this, you're multiplying your tails to add to the middle. I know that there's all these different algorithms for people to do the factoring. I always like to do this. What times what is negative 30 that adds together to get negative 1? What are my factors, multiples of when you multiply the ends that add to the middle? Well, what are your factors of 30? 1 and 30, 2 and 15, 3 and 10, 5 and 6. Which combination of those two plus minuses gets me to a negative 1? The 5 and 6. One of those has to be negative. Which one? Now, this is how you set this up then. So you have this, let me move this up a bit here. We have 2x squared minus 6x plus 5x minus 15 is 0. What I did is I moved the 0 to the other side. Remember, it can go on either side. It's not a big deal. And I'm taking this original quadratic and I'm splitting that middle term into something that I can do what's called factor by grouping. This is one of the methods that you guys were taught how to factor last year, and I use this one pretty much, really the only way that I ever use it, because it forces you to get the right answer. The reason that it forces you to do it, because this next step, if something doesn't go right, you know you're screwed up. So what we're going to do is we're going to factor out GCS twice. I group them. If I'm looking at that first set, I have 2x squared and a 6x. What do those two guys have in common? And x. Good. So I factor out a 2x. And I'm left with x minus 3. I do the same thing with the 5 and the 15. What do they have in common? 5. So I factor out the 5. Now here's the point where I was saying that if you don't have this part down, you know you screwed up. Are both the things that are in parentheses the same? Yes. If you can say yes to that, you probably didn't done goof. So you write it down. What are the other parts that are left? 2x plus 5. And that's how you factor that out to get two terms. Okay. Once you get to your terms, again, you set each term equal to 0 to find then the zeros. Terms and zeros, zeros and terms. First one's easy, just add the 3, what do you get? 3. The other one you would subtract 5 and then divide by 2, so you have negative 5 over 2. That gives you the two what are called zeros of the graph or of the equation. But since you have one that's positive and one that's negative, you always want to double check your negative to see if it actually does work. Negative 5 over 2 is negative 2.5, if I'm not mistaken, correct? So if I go way back up to the beginning here, we had 3 and negative 5.5. So if I look at this negative 5.5, or negative 5.5, negative 5 halves, or negative 2.5, negative 2.5 plus 1 gives me still a negative answer, doesn't it? Can I have a negative segment line? No. So I know, again, the negative in this case is what we call an extraneous solution. It's an answer, but it's just not an answer that we're looking for. So we just cross it off for this case. Again, there will come a time that a negative answer will work, just not today. Okay? Yes, ma'am. Okay. I told you guys, this is, algebra comes back in a really hard way right now. It's going to come back big time for this section. There's lots and lots of algebra. Okay? Leads us to our last one, last example side. Last example is when you have a secant, which is the one that goes through the circle at 2 spots. And then the other one is when it touches the circle at 1 spot, it's called a tangent. So if you have what's called a tangent and a secant, this is your tangent part. That's that secant again. We just dealt with ones that went through the circle. We had an outside and a hole. Well, we have the same thing here. We have outside, and we have a hole. So one part of this equation is the same. It's going to be outside times the hole. The other part is relatively quick. All we have to do is this. Take the tangent part, square it, and it equals the outside. There's a hole. and you get that. You take the outside part times the whole, and it equals that tangent part squared. Are you rolling your eyes at math formulas? You are, aren't you? Did they ever do anything to you besides give you problems? Let's see what I did there.
So on the first letter.
Which means you can do this. Hopefully. So if I try this one out, see what I'm saying? By being able to recognize one of these three pictures, the problems themselves fall into one of them. So as you do your homework and stuff tonight, I highly, highly, highly recommend writing down those three generic formulas on the top of your page. So you don't have to keep going back and forth, back and forth. It's right in front of you. Now, which of these two segments is the tangent one? It's the x, good. So I write it out in terms of outside whole equals tangent squared. So I get tangent part squared is outside times whole. The outside, or the tangent part is the x, so it's just x squared. What's your outside? What's the whole? So this is real tough. This might be the toughest one all day. 1 times 4.
5, 8, 7.
And then from. When you take a square root over an equal sign, what do you get? You have plus minus 2. When you take a square root over an equal sign, we do that on both sides of an equation. That means what are two numbers that are exactly the same that give you 4? Well, 2 times 2, or negative 2 and negative 2. But in this case, will the negative work for us? No, because I can't have a negative segment length. So again, I'm not worrying about the negative. It's an answer, it's just not an answer that I'm worrying about today. It's extraneous, if you will. Again, you will eventually have negative answers that work. That's why I'm kind of making you double check negatives all the time, okay? All right, I know. Another one that involves factoring and foiling and stuff and things and math. Lots and lots of pretty math. Oh, sorry, so I thought this was high enough up. Is that better? So you have a outside whole and a tangent. It's pretty easy to distinguish which one's which. One of them has 2 parts, the other one doesn't. Kind of a dead giveaway. So, which one's the tangent part? It's the 12. So I write this out in terms of algebra then. I will get 12 squared is outside times the whole. Okay. What's 12 squared? 144. Distribute the other stuff. It's already on the calendar. Now what? Subtract that over. You need to set aside equal to 0. And now you're again asking yourself, what times what is your tail? Negative 144. That adds together to give you a positive 10. Now there are a ton of different ways of doing this. My suggestion to you is start with what you already got. 12 times 12. That's not going to get you to 10. But what it does is give you a starting point. Okay? It gives you a starting point. What I would do is pick even numbers around 12. I'm not going to pick 10 because 10 times anything would end in a 0, but I'll pick 8. Use your calculator. 144 divided by 8. 144 divided by 8 is 10.
18.
Yeah, it's the 18. So one of those numbers, if I combine an 8 and an 18, how do I get it into a 10? Which one of those becomes positive and negative? Since this is not a 2 or anything, I can go right to this. X minus 8, x plus 18, 0 is an 8, and negative 18. We'll do a lot more of this tomorrow, but I want to give you the homework on here too. It's on page 693, it's section 10.6. I want you to do 3 through 15. Okay? It's like, I think it's 4 problems in each style. I want to say 2 to 3 of each style are really quick, and then only maybe 4 of these problems have a little bit extra algebra thrown in there, just so you guys are aware of where we're at, okay? Get those through tomorrow. We'll knock out more of these tomorrow as well. I'm guessing at the very earliest, testing is Thursday, but who knows? It'll probably wind up being Friday. That way it gives more time to grade it. Yay! Write these 3 things down on your page.